Let's do two probability calculations based on the following scenario. Suppose that in order for a widget to be made properly, the machine that makes the widget must perform 15 different functions properly. Each function has a 1.5% probability of failing, and the functions fail independently. We want to know what is the probability that a widget is properly made. Let's write our probability statement. We want to know the probability that a widget is properly made. When is a widget properly made? The widget is made properly when all 15 functions work. What has to be true when all 15 functions work properly? Function 1 must work, and function 2 must work, and function 3 must work, ... and function 15 must also work. Because the functions fail independently or work independently, and we are looking for the intersection of 15 different events, because of independence, this probability equals the product of the individual probabilities. And we have that this equals the probability that the first function works properly times the probability that the second function works properly, ... times the probability that the last function works properly. Now, what is the probability that a function works? We can use the property that the probability of an event equals 1 minus the probability of its complement to find this probability. This probability is the same as 1 minus the probability that the first function fails times 1 minus the probability that the second function fails, ... times 1 minus the probability that the 15th function fails. We know the probability that a function fails from our problem is 0.15. So 1 minus, this will be 1 minus 0.015 times 1 minus 0.015, ... 1 minus 0.015. This turns out to be 0.985 raised to the 15th power, which is 0.797. So the probability that a widget is properly made under the scenarios given in the problem is 79.7%. Our second problem is, what is the probability that at least one function fails during the process of making a widget? So let's write that as a probability statement. And our probability statement is the probability that at least one function fails. Anytime you have a probability calculation where you are trying to figure out the probability of at least one thing happening, it is much easier to find this probability by using the probability of complements. We know that the probability of an event equals 1 minus the probability of its complement. What is the complement of at least one function fails? The complement of that is that no function fails. What does no functions fail mean? This is the same as 1 minus the probability that all functions work. And we found that probability calculation in the first part of this problem. That is 1 minus 0.797, which equals 0.203. So the probability that at least one function fails is 20.3%, and our two probability calculations are complete.